Alright guys, this is Mr. Parham. I'd like to go over a basic projectile motion example problem. We have three things we want to find. We want to find total time in air, find the range of the projectile, and find its impact velocity. The projectile is shot horizontally at 15 meters per second from a height of 10 meters. Keep in mind, guys, that as soon as it leaves the cliff, gravity takes over and it begins to be pulled downward. When it hits the ground, it does not hit straight on, but it will hit at an angle. This is the impact velocity. The impact velocity has the horizontal component, Vx, the vertical component, which is the projectile's final y velocity. At the beginning, all of the velocity is horizontal, so I know this is the initial x velocity, and because all of the initial velocity is horizontal, I know that the y velocity at the beginning is 0. Now, once we have our picture, next will be organization. So I will list my horizontal stuff and my vertical stuff like so that I can stay organized. In the horizontal direction, the only three quantities I have are Vx, dx, and time. As a result, the only equation available to me is Vx equals dx over t. In the y direction, because there is an acceleration, I have the final, the initial, a, d, and t. Because I have all 5 variables and I have an acceleration, I have all 3 kinematic equations at my disposal. These you guys should be very familiar with, but I'll list. Now that we have our chart set up, let's place in what we know. I know initial velocity is 15 meters per second and it's horizontal. I know the initial vertical velocity is 0 because the initial velocity is all in the x direction. Acceleration is negative 9.8 meters per second squared. The projectile is going to fall a distance of 10 meters, so displacement in the y direction is 10 meters down. Part A asks for total time. And based on this information, I will use equation 2. So we have d equals v0t plus 1 half at squared. We notice initial velocity in the y direction is 0, so this is gone. Rearranging for time, I get the square root of 2 times the displacement over a square root. Plug numbers in. Once we do that, we get 1.42 seconds. Part B says find horizontal range. The horizontal range is this distance here, which I'll call dx. I know the time of flight is 1.42 seconds. I found that using the vertical information. Keep in mind with projectile motion that horizontal and vertical motions are tied together. So this 1.42 seconds that applies for y also applies for x. From there I can use my equation, rearranging for d. dx is dx times time. That is 15 times 1.42 or 21.4 meters. Now, to find impact velocity vi, I know, guys, because there is no acceleration horizontally, that the horizontal velocity stays constant. So I started with 15 meters per second. I will keep 15 meters per per second in the horizontal direction throughout the entire motion. That leaves me with the need to find the y final. So, looking at my information, I can use the first equation. So, VF is 0 plus negative 9.8 times 1.42. This gives us a negative 13.91 meters per second. So my triangle has 13.91 meters per second. Keep in mind, velocity is a vector. It has a magnitude and a direction. When I transfer that information up here to my picture, this is the magnitude. The direction is represented by my vertical arrow downward, which takes care of the negative side. From there, I have two sides of my triangle. I need the hypotenuse. So I can use Pythagorean Theorem. Impact velocity is the square root of 15 squared plus 13.91 squared, which gives me 20.45. From there I need direction, which is this angle here. To get theta, we'll use our favorite trig function, have the opposite side and the adjacent side. So I will use tangent inverse of 13.91 over 15